The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome and thank you for attending this morning's webinar, The Benefits of 3D Laser Scanning. My name is Marissa Davis. I'm Marketing Manager here at G2, and I'll be facilitating for you this morning. So I just wanted to start by taking a couple seconds to say that we hope you and your families are staying safe and healthy in the midst of all this craziness happening around us. Today's presentation will be the first in a series of webinars that we'll be hosting for a few reasons. First, we had a number of presentations that were ready for various conferences that were postponed or canceled, so we thought we would take the opportunity to still be able to offer them to you just in the form of a webinar. Second, just to provide you folks with some interesting and relevant topics, and lastly, to hopefully be a distraction from the daily press briefings, the all-day Zoom meetings, and trying to keep the kiddos busy and entertained while still trying to make sure they do their homeschooling. Trust me, I feel your pain. With that said, let's get started, and I hope you enjoy. The host of today's webinar, G2 Integrated Solutions, provides responsive support in a comprehensive suite of asset integrity, engineering, GIS, field services, regulatory, and technology solutions that address asset performance through its lifecycle. For more details on our services, please visit our website at www.g2-is.com. All right, so now I'd like to introduce you to our presenters, Mark Tribig, Eric Cowan, and Heidi Stanfield. First, we have Mark Tribig. He's Vice President of Engineering here at G2 with over 35 years of industry experience as an operator, a contractor, and as a consultant. Mark is responsible for overseeing our engineering teams and projects. Next, we have Eric. Eric is G2's Vice President of Field Services. He's got 20 plus years of industry experience, and he currently oversees the field inspection services for G2. Heidi Stanfield is a project manager here at G2 with 35 years of electrical design and EPC experience. So we do have a lot to cover this morning. We'll save questions for the end of the webinar. At any point during the presentation, you have questions. If you want to just go ahead and submit them through the question function, we'll be happy to answer them at the end of the webinar. And at this point, I'll turn it over to Mark.
Good morning, everyone. And just to build on what Marissa said, if we have a significant amount of questions at the end, and we hope we do, we would plan on recreating this webinar just from a Q&A perspective sometime next week. So, you know, if you don't have a question now, if it comes up, please send it in to us, and then we can, again, we would add that to our list of things we would want to have further conversations with everyone about. So just to kind of put the agenda on the board for you, you know, we're going to have some questions we want to ask you. We've got, we're going to give you a brief history of 3D LIDAR scanning, how it works, why use LIDAR instead of traditional as-built methods. We're going to give you a comparison of the older scanning, the older LIDARs versus the current technologies. We're going to briefly go over our scanning procedures that we do, and then we're going to go over why we believe more scans rather than less are important and needed, and then we'll talk about the economics of the current state of technology. Here's some questions we want you to ask. What if you could walk through your as-builts? What if you could walk down the components of your P&IDs without having to leave the office? What if your as-builts could be visually linked to show past, existing, and proposed construction? What if your project stakeholders had never been to the site and you wanted to share progress without disrupting an entire progress? How can you share your solution without expensive travel to the site? Have you ever needed to walk your contractors through a running facility to view a potential project where safety may be an issue? Have you ever needed to add to a facility when you knew the existing drawing sets were out of date and new as-built were not in the budget? What if a major construction project is underway at your facility? How do you document the progress? What do you document? Have you ever toured a construction site and forgot to take enough photographs, measurements, red lines to fully document a potential problem and potential solution? Have you ever needed to travel back to a site to collect additional information? What if your engineering team is remote and in different offices? Have you ever wondered how you're going to discuss the project scope with various locations and groups without the need to visit the site? What if a pandemic disease has infected the country and all non-essential travel has been eliminated? And have you ever really had to deal with a complex operational problem without access to the actual facility? These are some of the questions we wanted to have you start thinking through, because that is where, in fact, LIDAR comes into play. What's the solution available? 3D laser scanning. LIDAR, which is a combination of light and radar, are actually an acronym for laser imaging detection and ranging. It's been around since the 1960s to model clouds and large geographic features. The USGS used it and a few other folks, but it didn't break into the engineering realm until the late 90s. It was one of those technologies that could not advance fully until bandwidth and hard drive storage increased and became more economical. And even today, the scan data, what is called point clouds, typically have to be delivered on external hard drives or very large thumb drives because the files are too large to email or even to FTP. It's a 360-degree scan of everything in a facility visible to the naked eye. The current technology of scans can capture up to 2 million data points per second versus a million data points per second as best in class as recently as 5 years ago. But this was actually a different type of technology and limited to the number of manufacturers who produced it. The technology on the scanner that we use, the manufacturer, their best at the time may have been 50,000 points per second. With the technology we have, we can do a full 360-degree scan with pictures in less than 3 minutes. And the older technologies often require 20 to 30 minutes per scan to complete with a lot less resolution. Our scans and point clouds are tied to control points in the GPS coordinates. Now, the one downside to anything you do with LIDAR, if it has to be visible to the naked eye, below ground piping and other structures that are hidden, that are buried, they're not, you won't be able to get this information from a LIDAR. You're going to have to rely on alternative technologies such as ground penetrating radar. So why would you use LIDAR over traditional as-built methods? Well, the traditional methods, as most of you know, would include survey or field measurements. They would include inspectors' notes, survey notes. They would include pictures or movies, field red lines, either from inspectors or from, other people going out in the field and drawing it up. They would be based upon client drawings, old client drawings, whether those may have been construction issued for construction, they may have been as-built. We, for a variety of reasons, had to use drawing sets that were even issued prior to an IFC, for instance, and those are not always up to date. And the deliverable was, typically a pen or ink drawing, or, nowadays it's either a CAD 2D or 3D model. LIDAR is repeatable and verifiable and much more accurate. The pictures and point clouds do not lie from the scans. It typically nowadays, because of the time to take to a scan, it requires less field time than to the traditional as-built services where you went out and pulled tape and took pictures and wrote down and sketched and did all those kinds of things. You can reduce or eliminate costly return trips to the site if you forgot a measurement, if you forgot to take that picture, if there's too many things that happen while you're out there that you forget. Something happens, you got a phone call and you forgot to catch something. The scan doesn't care about a phone call. The scan does what it does. You get shorter project cycle times at the end because you're able to bring back, you got a more complete entity. You don't have to worry about pulling, trying to read somebody else's writing. You get safer data capture. There's a vast amount of collateral data collected, which is a significant value add for maybe not for the drafters, maybe not for the engineers, but for the rest of your organization. The information collected can be completely overwhelming in the amount of information you get. You can do with the scanner that we have, you can scan in total darkness. So if it hadn't to be, you couldn't put the guy, set the guy up in the middle of the night because you're not working and you don't want to disrupt construction, you can scan in total darkness. You can scan inside of a tank without any lights. So it's a significant advantage to utilize the type of scanner we have. The scanner does not need to be level to work. It will self-adjust itself. It could be lowered into a confined space on a rope without the need for manned entry and you still get accurate data. It's able to self-register all the points, which eliminates a time-consuming step, which always was a problem in the past. LIDAR-based as-built offer several advantages over traditional measures, including accuracy, speed, cost. You get more complete image files. On the long-term record-keeping aspect, you get an accessible permanent record, which can be added to while keeping the old history. The one disadvantage, and it's an advantage because there's you're going to have significant digital storage required due to the size of the data files. It's a disadvantage if you don't already have that in your organization. It's an advantage in the amount of data that you have available to you for future moving forward. A couple of things you want to discuss is the point cloud. As the newer technologies, the point cloud becomes better. So the point cloud defines the shape of the real and created system. As you can see on the lower image, this becomes the base of your as-built. We were able to overlay our model. We drew over the top of it and got a dimensionally correct representation using an AutoCAD program. This point cloud can, it becomes the historical document. It becomes the document that the engineer uses, that the construction guys use. What are some of the advantages of using LIDAR imaging? And then I'm going to turn it over to Heidi. She's going to talk a little bit about those.
So what we have on this slide is basically our brainstorming. We have a base LIDAR scan of your facility. So what could you use it for besides just the means of using it for design? One thing we looked at was facility management. You can use this then to, following a natural disaster, have it for insurance purposes. It's like having a movie of your entire site. There's no arguments then with an insurance company. Or you have to go back in and order your piping, order your valves following something that a natural disaster. How could you quickly get things back to your facility? You can look at it for design support, as Mark has already talked about. We're also looking at it for computational fluid dynamics. We can use the LIDAR scan of, say, a compressor station and internally look at if you had a gas leak at this point, and we know where your fan is, we know the thermal properties of your engines, we can look at where that gas would disperse to. You can also use the CFD for berm analysis. How much liquid can that berm contain? It's really best use, I think, is for records. It is your living, breathing document of where you're at today. And that record then can be used for other people besides engineering. It can be used for your process group, safety group, your operational people. You can also use it for tank inspection. Eric will talk to that in future slides. You can also use it for process safety analysis. You could use it for training. You could walk through the site. You could use it for 3D views of your area classification. And if you took that plus the CFD, where you knew where your points of ignition were, and you had wind, and you had the wind speed, you could actually track where that gas plume may go and what it could ignite to. We're looking at and testing it with our GIS interface. That, because it is a geo-referenced data set, it would lend itself greatly into that GIS. And the last thing, which probably today is the most important, is telepresence. You have the ability to see your facility, to walk through that site, and then to communicate with someone remotely. This is what I'm looking at, and this is the problem, and what could we do? And with that, I'll give it back to Mark.
Thank you, Heidi. As she mentioned, one of the key attributes of using a LIDAR is telepresence. And again, with the fact that we're all sitting at home because of the COVID-19 experience, well-designed scans, all departments within an operating company would have access to an as-constructed electronic file, which includes high-definition photographs. In the event you got operating problems, you know, everyone who has an interest in solving a problem, and I come from the gas transmission industry, so you know, gas control has interest, the operations guys have an interest, the corporate engineering guys have. All of those folks could be on the same phone, could be looking at the same set of information and help and walk through and solve problems, and they can all do it from their offices or a conference room rather than have to be on site. You know, with construction projects, the point cloud and image files can, you know, you can do, especially for minor projects, if you have it and you need to change out a valve, you need to change out a meter, you want to change out a piece of equipment, you could obtain accurate measurements, including you could look at the routing and interferences. You could determine how best you're going to have to bring equipment in and set up. It gives you a tremendous advantage rather than have to be out on site. From an engineering, you know, the point cloud and image files, as we kind of showed earlier in one quick slide, that can be used to 3D model facilities. You can develop accurate P&IDs remotely. You can update old drawing files with up-to-date information. And the last two are just as important and intriguing to me somewhat. The point cloud and image files can be used to complete most of the preliminary training of new employees from an office or training center rather than have to take them out to a field location. You know, inexperienced people sometimes are going to be in the wrong spot there. They may touch something that they shouldn't be. You can eliminate all that. You can get them enough experience so that when they do show up for the first time, they've had the benefit of some training. And first responders, you can use the point cloud and image files to go do desktop exercises with them rather than needing them to tour the site, so they can look at access, response, setups for their equipment. How would they best, you know, attempt to let's say fight a fire or, you know, extricate somebody, you know, in the event of a disaster. The LIDAR scan allows an owner-operator to remotely provide access to stakeholders and coordinators and contractors. It allows the engineer and the construction team to review the feasibility of a project and the constructability of a project. You can dry run your maintenance and construction moves without having to be there. You can figure out where you're going to have to set up. You can figure out interferences. Can you get a crane underneath a pipe rack or anything? You can do all that without having to be there, and you can support safety and first responders. The base LIDAR scan with the piping improvements overlay gives you a tremendous advantage with your engineering support design. Number one, you can see in real time, real life, that your model is correct, and you're able to then get it dimensionally correct. You can send that to your fab shops to build all your equipment, to build all your pipe. You would only have to rescan what was already changed after construction for a new as built, for instance, if you've already done a previous scan. And in cases where you're actively under construction, you can scan different days and different weeks or whatever, so that if you haven't covered up buried piping, you can scan it while it's still uncovered and then have that dimensionally correct as well. So at the end of the job, you have a complete as-built file with both above ground and below ground installations that can be updated with additional scans as not only construction continues, but later on, a year from now, 2 years from now, you can completely start validating changes. You can see, you could see pipes, you could see pipe supports, you could see tanks, you could see equipment. If it starts to subside, if it starts to sink, you can see day to day, year to year, decade to decade, you can see changes in your facility because the scanner, the scanner doesn't lie. It ties to a hard point and everything can be based back onto that. So it's a significant tool, not only for current, but for historical, and again, moving forward, you can do a lot of your maintenance work moving forward. The scanners nowadays are so good. The point cloud, as you can see, I've got a point cloud image up against a photographic image. The point clouds with enough scan data, and the picture you have here, we didn't probably scan near as many points as we would suggest, and it's almost photorealistic as it is. So you get a tremendous benefit from the point cloud with additional scans. The point cloud is where you could do the fly-throughs, you can do the walkthroughs, you're able to visually see the whole facility at once. It's a tremendous tool. From some of the other supports, you can do you can do a 3D scan of a tank berm. You can determine whether or not the berm itself, based upon some of the tools that Eric and his team use, to determine whether or not you have adequate containment. Whether, if this was a new one, and then you can go through time. What happens after a hurricane comes through? Has it affected the height of your berm? Has silt gotten into your containment? Do you have an adequate containment after a seismic event or a weather event? Do you have a low spot? Did you have a washout? Did a guy, did a bulldozer hit the side of it and knock a little hole in it and just knock 6 inches off the top of a berm in one area? You can determine all that accurately and repeatably using LIDAR. It can be used to develop 3D area electrical classification drawings. You can model, as Heidi alluded to, you can model various scenarios using for CFD, for vapor dispersion within buildings, for external. You can do ignition source determination. You can determine egress scenarios, both in, out, how to set up equipment for whether it's safety, whether it's first responders, whether it's just construction without the need for a field visit. You can do tabletop drills with your first responders, without having to put them in a situation where they're in harm's way. LIDAR point clouds can be integrated into ArcGIS models. It's an extraordinary thing nowadays. The models are so strong that they can import that amount of data. So you have a 3D model in your ArcGIS. You can do gas, HCA, MCA analysis for those, again, who are in the pipeline world. You can do liquid HCA analysis. You can do dispersion modeling on liquid. You can do gas plume. All of this can be done by putting the facility into an ArcGIS and then using some of the tools that are available out there. And not to get into the sales pitch, G2 has some of these tools as well as a lot of other good companies. So it's a great tool to have and a great model to have. You can do vegetation control and you can do safety systems. It can be used as an asset management tool. It's easily shared and reviewed with others. Most of the viewers that are needed for the information are free viewers. So once the file is set up and shared with the client and shared with the company, then everybody can use a free viewer and look at the same information. So you can do dimensional data, you can walk through sites. That can be all done through these free viewers. You really would only need to develop those drawings needed because you already have all the data available. So your drawing sets don't necessarily have to be 15 pages. They can do one, they can be two, and you can still tie them all back to your model. You can do volume determination and monitoring, as Eric will get into. You can do construction quality assurance. You can check progress week to week, day to day, month to month, however you need to do. You can, we've had instances where we've scanned a tank, a hurricane came through, the tank got damaged, the insurance company didn't want to pay. They pulled the old scan out and said, look, man, it was right before the hurricane, it's hurricane damage. So that kind of information is invaluable to a lot of the organizations within your company. And you can incorporate the GIS and HCA analysis, you can incorporate it into all of those other things that I previously mentioned. So I'm going to turn it over now to Eric to talk about 3D scanning and reporting.
Thanks, Mark. Well, good morning, everyone. I wanted to go over with you just some of the stuff we use 3D scanning for in our API 653 tank inspections. And we'll cover a few different things, about 5 or 6 slides worth, and we'll show you some really neat images along with the fly-through video at the end where you can kind of really see what some of this point cloud data that Mark's been talking about will do for you. Some of the things that you're going to hear me say a few different times, and you'll see on some slides, is 100% coverage and nothing missed. What that really means is just like Mark's mentioned a few times, that scanner is going to collect 100% of your asset data every time it collects. Traditional methodology for inspecting a tank would be a crew out there with a total station, some plumb bobs, some man lifts going from top to bottom, inside and outside, 8 places around the tank, 10 places around the tank, 12 places, whatever that may be, depending upon the size of it. With the scanning, we get 100% coverage of that tank. So we'll show you some of that stuff here on the next few slides. Go ahead, Mark, move to the next one, please. So what you see here, you got this really colorful, what looks like a thermal image on the right, and then you've got some 3D reporting pieces on the left. That image on the right isn't actually a thermal image. What that's showing you is the deflection of your tank shell, both in and out. And it gives you a good representation all the way around that tank of showing you where your tank wall is bulging in or sucking in, if you will, depending upon what it's doing. And it allows your office people and your higher ups to see, hey, this is what our shell is doing. All of this is within code. It's okay. It's normal. But just so you know, these intense red areas or intense blue areas, we may have some problems in the future. And again, on the left-hand side, again, you'll see 100% coverage. Again, we're going to collect everything top to bottom, inside and out, on the roof as well. Some of the things you're going to see on that, you'll see edge settlement. We're going to get edge settlement all the way around the base of that tank. Again, not just in certain areas, we're going to get all of it. Shell peaking and banding, again, you're going to see all of it all the way across the tank, all the vertical and horizontal welds that hold those plates together. Rafter girder assessment, and rafter and girder assessments is a nice one to talk about because that also adds another piece that the scanning gives us, which is safety. Traditional methods, we got to send someone up in a man lift, have them strapped up there, tied off, inspecting those girders and rafters, checking all that stuff, making sure they're all good. With the accuracy of these scanners today, we don't actually have to send anyone up. We can scan the data, take it back into the software, zoom right in on it, look at all that stuff, and then if we need to, highlight some certain areas that we might want to have someone go verify. But most of the time, you can get everything you need from that scan data itself. Column analysis, are the columns twisting the same way? Are they twisting at all? Do we have doing anything differently that might give us some different edge settlements or some floor issues? Again, we can see all of this with that scan data. Nothing additional needs to be collected for that. And as Mark mentioned a few slides back, berm containment. So initially, berms are built to basically hold in as much liquid or whatever you have contained inside that tank. We can scan for that, give you some analysis and let you know if you have it, but we can also then do it for a catastrophic release. What if during that hurricane something hit the side of that tank and it punctured it or it ripped it? Do you have the ability to hold back a catastrophic release of that liquid that's in there? If you don't, what's it going to do? Our model will show you where it's most likely going to spill over your berm and then where it's going to go from there. Next slide, please. Here you've just got some more nice colored imagery on the right, and the middle there you've got your bottom settlement curve, which again will show you how all that stuff sits there. Again, 100% coverage. We're giving you a look at your asset all the way around top to bottom. It will capture all structural categories that will allow us to then do some automatic reporting. That reporting is done with some software that we have created, as long as with some of our third-party software vendors. But with that scan data, that single set of scan data that we collect when we're out there, we can do all this reporting without having to go back. No comparison to traditional technique. Again, it's 100% coverage, nothing missed. And there's a huge amount of time savings. And what we mean by a huge amount of time savings is, if you were to try to get close to this much data in a traditional method, it would probably be out there for several months. A standard 250 foot to 300 foot diameter tank, we can do all the scans in about 2.5 to 3 days. That collects everything. We'll verify all that data in the field before we leave, and then we can go back to the office and do our reporting. Next. So this slide and the slide we're going to look at next is going to show you some of the actual reporting that we can turn into you with this stuff. And what you see on the left is a look at your shell if you're looking at it down from space. It does look a little weird, but we have to remember that this is a 275 foot in diameter tank with a 6-inch scale here. So what you see is every scanned data at every 10 degrees on that tank. So as you're looking at it, there's a different line for every 10 degrees. So if you look on the right, you'll see all of them stacked on top of each other. So at 0 degrees, 10 degrees, you can see what that tank is doing. What this really does is it kind of just gives you an overall one-shot look of what your actual tank is doing. So we can go to the next slide, please. Now here you have it broken down. And in this particular case, we were given instructions of give us as much data as we can. So what we gave to this client was shell and edge reporting at every 1 degree around the tank. So they got a report for 360 degrees around that tank. You can see the 6, 7, and 8 degrees here, where you can see what that tank shell is doing from the bottom at 0, 0 to the top at 560 or at just under 60 feet, just under 50 feet. So it's showing them exactly at one degree around. Now you may have us come in and do it at 15 degrees or 20 degrees, come back a month later and say, hey, can you show us what's going on between 0 and 45? We can rerun that report from that scan, not have to go back out there and give you all that data again. Nothing's missed. We have it all. We can show it and run the reports. On the right-hand side, what we have here is basically a 180-degree comparison. So at 51 degrees, directly straight across that tank at 231 degrees, what are we doing? What's happening? We're showing, maybe in this case, it's a floating roof, and we're showing a little bit of a escape of some fluids out of it. What's happening right there? We can see that the tank shell is actually pushing out a bit. Maybe that's our problem. We'll give you this all the way around at every degree if you want, again, at every 10 or 20 degrees. Allowing us to have that 100% coverage allows us to give you much more data without actually spending any more time on the field. Next slide. And this is kind of the fun piece of all of this. The data is neat to look at, but this is actually a point cloud video. So we'll go ahead and start it, and you're going to see a fly through of this tank. This is taking the actual scan data, having it as a point cloud fly through, and now we're going to see the inside. We'll see the floor. If you look at the floor, you'll be able to see where the plates are. You'll be able to see what the floor is doing. The different colors on the column showing you the rotation twist that the columns are doing. You can again see the colors on the inside and the outside of your shell. What's happening again with, and it's also with your roof structure. We'll fly out. You'll see the overall look. And then, this is a great tool for you to give to someone that has maybe not been out to the tanks farm before, wants to see some data that explains to them why you're asking for the funding you're asking for to repair it or replace something. And then again, for higher ups that maybe have never been out there, that's just an idea of what you guys have in the field. So those are just a few slides of some of the stuff we do with the scanning on the tank side. So I'll go ahead and turn it back over to Mark to wrap it up.
Thank you, Eric. Our next topic is going to be comparing some of the older scanning technology and methods versus the newer methods. So on the left side, you can see a similar sized facility in the older scanner, and it's only about 5 years old. That what you're looking at versus the newer one. You can see it's a lot grainier. It's a lot more difficult to read, and you don't have near the clarity that you would have had with the newer technologies that we have. And you know, the amazing thing is every one of this for both of these, all of the scanning was done on the ground, and you're still able to get a plan view look at your facility. As you zoom in closer and closer, you know, the granularity starts to go away. You start to get a little bit better image set of the receiver on the left-hand side, but as you can still see at roughly the same zoom, it's still much clearer with the newer technology, because again, there's you get so many more data points for each individual scan. You get a situation where, based upon, because it took so long to run each scan, you weren't running near as enough, so you get images sometimes like on the left-hand side where it looks like that receiver is curved back around, which we all know is not correct. But you can look at the right-hand side again, it's almost photorealistic, and that literally is a point cloud. That's not a photograph we took. So now you get to the photograph aspects of it. Well, the old type of photographs were kind of a mosaic of several hundreds of pictures that were taken and then stitched together, whereas the new one is a full 360-degree panoramic image. And again, you can just see that you get better clarity, you're getting more pixels, it's just a better photograph. The one thing that still exists on both ends, which is another why we're going to a topic later on, you still get this fisheye look. And the fisheye look is the reason that we believe that increasing the number of scans will minimize the impact, will minimize the fisheye look. As you can fly through, you can improve, you can go in and do more accurate measurements. Our procedure that we are currently working on, we would advocate scans at a density of every 5 to 10 feet. And you're going, my God, man, how long is that going to take? Remember that these scans, the newer ones, only take about 3 minutes to complete, where the older ones would have been 20 or 30 minutes. So you can get a significant increase in the number of scans in less time than it took just to do one in the old way. So the scanners that we have are capable of integrating large facilities into one file, and the image you see took about 4 days to complete, and we were able to meld them all together into a single homogeneous view. So that's the one thing that is really neat about 3D laser scanning, is that old files can be used with new files. You can scan on multiple days and stitch them all together, and you don't lose any clarity and any resolution because the scans occurred on different days. So as you start zooming in, you can merge in large facilities and still maintain the same detail and clarity that you always had. And in fact, you've seen this picture before. Multiple days, multiple scans, you still, because of the technology that you still have almost a photorealistic view on your point cloud. And the point cloud is the bread and butter of the whole scanning exercise. It's where you are able to do your scans, and you're able to do your measurements, and you're able to do your walkthroughs and your fly-throughs. the photographs are nice, but they're a point in time. They're a point, or a hard point, and you can only rotate around them. Whereas with the point cloud, you can walk the length of your model. So we use this is a picture and a representation of the model of the scanner that we use, and we've got some of the performance deals off the spec sheets. And Eric, if you want to chime in here and talk a little bit about this, I'll let you.
Sure. This is the Leica RTC 360. We looked at several different models, mainly for our tank inspection side. It's kind of morphed into some of the engineering pipeline side. Some of the reasons we like this one, the highest resolution we can run it at is 2 million points a second. As Mark said, that takes about 2 minutes and 45 seconds to run a full 360-degree scan with images. It has 6 cameras on it, so it's getting the sides and the top images as it runs through. It can be used in total darkness. We can run it into a tank with absolutely no light, and it will collect everything as if it was daylight. Another nice thing with this particular unit is it does not have any issues with anything that's painted black or darker colors. Some other scanners still have some issues with dark colored objects. Doesn't pick those up well. The Leica does really well. And one of the really nice features of it, as Mark's mentioned, is the auto registration and the built-in GPS. So as we pick it up and move it, we see on the iPad where it's been and where it's going to, and then it connects those scans for us. So we're able to see in the field before we even leave if we've collected everything we need, where all of our data is. Does anything look off that we should recollect? So the point there is hoping to not have to come back out into the field afterwards. And those were the main reasons why we chose this unit. We've been very happy with it, and I would definitely recommend it as a unit for anyone's projects if you are ever looking for one on your own.
Thank you, Eric. So our current tech procedures that we do, and again, this is based upon us doing several scans. We've done them wrongly, we've done them correctly. This is based upon our experience and where we think we've come to, and we believe this to be the correct way to do it. We would always have a pre-planning meeting to determine the approximate number of setups for locations, the scope, so that it does help us, number one, keep the cost down. We do as G2, respect your money. And so, we don't want to just go out there and haphazardly and look like we're just, a bunch of clowns to start off of the project. We're going to go out there with a plan. So once on site, once we've established our plan, we've got notes, we have an orderly progression that we're going to do. But the first thing we do is establish a base point. The way all these scans work is they're all tied back to the first scan. So having a properly located base point allows you to be able to tie back ultimately back to your, if you're working off a grid, a station grid, we can tie back to that. If you're operating off if you don't have a station grid, we can help you define one. It will all tie back to, ultimately can be tied back to, the real world, the lat longs, real world coordinates. We can do geo tagging, and that is a really cool thing. It can be done real time as you're walking through the scans. And then once you're done, and we'll talk about geo tagging a little later. Once you're at completion and the scans are downloaded to an external drive for post-process, and then to bring it back to G2, and then we can stitch them together. We can generate an overall point cloud. We can be used as a variety of uses as we've indicated. And as Eric mentioned earlier, because everything is registered in the field at real time, you don't have to send the data set off to some other company to make sure they get all the data points correctly registered. The second the scan is done, we can bring it back into our office and start stitching it together. So you don't lose any time based on that. So why do we advocate for more scans? Because again, in the old days, it took so long and everything that scanning was never an attractive, option for day-to-day activities. It never was an attractive option to do some of the things we're talking about. But because of the increased scanning speeds Eric alluded to, we can do a full scan, 360-degree scan in under 3 minutes. We can get 3 to 5 times the scans that used to be done using the older technologies. And by having more scans, you can eliminate blind spots. As we've already said, anything that the scanner can't see that's the same thing you can't see with your naked eye. If it's blocked by a piece of equipment, if something is blocked by a valve, if something's blocked by a building, the scanner's not going to see it either. So now you have a blind spot. More setups, more scans, more availability eliminates those. The multiple scan setups is what we're talking about, would eliminate blind spots. You'd eliminate half pipes and equipment, and we'll show images to that effect. You eliminate double or shadow images. It's the same deal. More scans, better setups, better planning will eliminate all that. And then ultimately you improve the accuracy and legibility of the point cloud because you got more data points that you're going to use. Shadows are a problem at times, and we've got one here where it looks like there's a complete disconnect on this is a launcher barrel. It looks like that, you don't know what is going on there. Now our drafter, a senior level drafter, as he was working through this, knew that was not an extruded T on this barrel. He knew that it was actual an actual reducing T, and because he was able to find by zooming in and looking at it, he could see the weld line. So we knew this was a reducing T, but we also knew that was a 3-inch T and that valve was just 2 inches. So there is a 3x2 or 4x3, I don't remember what it is, reducing T that's in the way. Our drafter knew it, he was able to pick it up, but you don't know that by looking at what the scanner is. One more scan on the long end of the barrel would have taken care of that. And so again, that's a perfect example of why additional scans would help you, and a better plan would help you. We did some of this on purpose just to kind of show what's going on. The images that you're seeing here were from a scan job that we were working on and set up a long way away from this end, and only use a couple of scans to pick it up. And what you're seeing is on that upper image, you kind of have a shadow going on. It's because the scanner was not close enough to the particular piece of pipe, and as Eric alluded to, you can you're picking up under a 2 millimeters at 10 meters. It drafts off to about 5 millimeters or more as you get farther and farther away. We were a good distance away from this piece of pipe, and as a result of that, you weren't able to properly stitch the images together because the points are so far apart. The other thing is, if you look at the other two images, we've got a top view and a side view. You only have a half a piece of pipe because we didn't scan on the back side of this particular piece of pipe on purpose to be able to show the impact of not enough scans. So the farther away, the fewer scans, your point cloud is grady, you get half pipes and you get double images. So more scans eliminate every one of these problems and give you a better product at the end. So, let's move into, this is about a 20-acre facility, and using the older technologies, there was 85 images shot for this particular site, and it seems like a lot. This took over a week to do. but it doesn't give you near enough data in a lot of critical places because, again, you weren't able to get the setups necessary. You have shadows in here, you have incomplete images, you have places that no image was available because it was blocked. Using a newer image, and this is the exact same site, and this is part of what, you know, we're talking about doing some of our planning and disregard the fact that he's got all these squares over. These squares are, each one of the smaller squares are a 10-foot or a 10-foot box, and so it's the green one is a 100-foot box. And so we were putting these 100-foot squares over the top of the particular site during a pre-plan to determine where we needed to do setups and how many. Again, we're not going to, none of these boxes are implying that there would ever be 100 scans set up in any one of these areas. Some of these areas would have 20, some of them would have 25, but this lets us plan on how we're going to do it. In the same time period to do that other scan that took over a week, we could do over 500 scans versus the 85. So that's, you know, that's 6 times the images, 6 times the data points, 6 times the setups and the ability to get better data for the same cost. And for us, that's a significant improvement. It allows you to do so much more. It allows you to do better walkthroughs, better fly-throughs, better, you can do P&ID reviews, you can do your safety, your accessibility. All of those things add to the, you know, to the data set and add to the operational ease that more scans do for you. The scans can do multiple levels. So you can start, because it's self-registering and because it's tied to a GIS, the scanner knows where it always is, and it knows where all the other scanners were. And I'll show you an image here in a minute. It kind of shows you how these tie. So you can shoot multiple levels. This one is just happens to be the parking garage back behind our building. But, you know, within a plant, within a refinery, even on a tank, you can go up and down. You can set off of multiple levels, and all of those are tied together before you ever leave the facility. So it allows you to walk through. It allows you can do walkthroughs. You can go through this. You know, you can go through the floors. You can go up levels and see how individually everything ties together. For interferences, it's easier to do your drafting. You can do your P&ID walkthroughs for all those types of things. The green line it kind of shows you how, and this was how each of the individual scans tie to each other. Each one, basically the order we did them in. And all of these scans are actually on the first floor of this parking garage, not on the second floor. But again, that's just the way the deal does. But I put this slide in here to talk about geo tagging. And so in particular, I'm only going to show one, but the little ice cream cone looking thing is tied to a specific place and a specific item within this scan data. And so I just highlighted it. And so what you do is you go in there and you you come in behind it with either your iPad, your iPhone, whatever device you have, and you specifically point it and say, I want to tag this area. So what we did is tagged a caution sign, and then you can take a picture of it, and you can get really in tight, really in close to that. So if you want to tag a valve tag, if you want to tag an instrument tag, if you need to tag a hot spot, if you need to tag a bad bolt or something from a construction job or a bad weld or whatever, you can come in, you can geotag these things, you can take really, really, really high resolution detailed images, zoom in and get them so that you're able to come back later on and take care of a lot of the things you may have identified. It's a really powerful and really cool part of this scanner. So now, having gone through all of that, why should you scan? Well, I've got 2 different examples here. And one of them is that facility that we just got done. And then the first one was the, when I used the example for the old versus new technologies. The smaller sites, in the old days, you may have set up 6 times, and even that may have been questionable. And because it took 20 minutes to scan, but then, additional time to move up, set up, so we just kind of use an average of 30 minutes. Six setups on a site is going to take you 3 hours. And even when you add in everything that's going on, it wasn't expensive, but it wasn't all that cheap. It's still cheaper than if we'd have sent a crew of folks out there to draw it up. We would typically send 3 people to draw it up. We'd be there at least that same amount of time. Either one with the scanners, whether the old or the new, you'd only use 2, so you're already got a 30% advantage using scan versus going out there and pull and take. Now with the new scan, instead of it taking 30 minutes to set up, if it's 5 minutes to set up, we can do 3 times as many scans in half the time and less people. So rather than it being a $300 cost to you, rather than being a $600 or a $900 cost to you, because if you did it the old way, you can do it for $300 roughly. Now that doesn't count travel, that doesn't count any windshield time, but the time on site is substantially reduced if you're not taking an enormous additional amount of times, and the smaller sites wouldn't need it. Now that older one, we would, and you saw why we would suggest that. But even at that, instead of 85 scans, you could do 500 scans in the same amount of time that it would have taken you to do 85. You get so much more data, you get so much more clarity, there's so many more advantages to doing multiple scans that, again, based on everything we've gone over, it's just not an engineering tool. It's an operations tool. It's a safety tool. It's a tool that management can use. It's a tool that's incredibly important for everybody in your company. And with that in, I'm going to go to questions. So we still got a couple of minutes, and I'll let Marissa, if anybody called in, I'll let her read them and we can try and answer them.
Sure. So I think I'm going to try and keep everybody to the schedule, and I don't want to run anybody past 11. So how about we do this? If you have any questions after this, please feel free to email either Mark or Eric directly, and they'll be happy to get back to you. And I'll send that information to you over an email, because I'll also be sending you a copy of the presentation as well as a link to the recording over the next couple of days. So, and like I mentioned in the intro, this morning's presentation was the first of many weekly webinars that we have scheduled. So make sure to be on the lookout for upcoming topics that may interest you. And if you want, send me a note with topics that you don't see on the schedule that you might be interested in seeing. We hope you have a great rest of your day, and we hope to see you back next week. Thanks for joining.
Thank you, everyone.